In this video, I'll be covering P0108, map sensor signal voltage high. The information, schematics and diagrams in this video are typical of most systems. Make sure you have the correct information for your vehicle. Here is a typical schematic for a map sensor. There is a 5-volt reference, a low reference, and a signal return going to a pull-up circuit within the engine control module or ECM. Some systems use a pull-down circuit for system monitoring. As the manifold pressure changes, the signal back to the ECM changes. This change can be a varying voltage or a varying frequency. The amount of change will reflect the manifold vacuum pressure. The fault table indicates that a P0108 could be caused by a shorter voltage or an open in the signal circuit, or an open or high resistance in the low reference circuit. Even though this fault code requires us to check the circuit, it's a good idea to start with the basics. If available, check the freeze frame data to see the conditions when the fault occurred. With the engine running, observe the scan tool parameters. It's best to use graph mode if available. An oscilloscope can also be used. Look for anything unusual in the pattern while operating the engine through a variety of RPM ranges. Check the integrity of the air induction system by inspecting for any damaged components, loose, improperly installed or routed vacuum hoses, any vacuum leaks or intake restrictions, and a missing or damaged map sensor seal. If in doubt, use a leak detector. Make sure that the engine is mechanically sound. Check the exhaust system for any restrictions or damage. Start the diagnosis by checking battery voltage and disconnecting the sensor. Test for 12 volts between the low reference circuit terminal and battery positive. If less than battery voltage, there will be a resistance in the circuit or a fault in the ECM or ECM connector. If there is no voltage, there will be an open circuit in the harness, the module connector, or a fault in the ECM itself. Move the meter lead from the sensor terminal to the next connector in line. In this case, it will be the ECM. Back probe the connector and retest. If battery voltage is present, then there is a resistance between the two connectors. If the voltage is still low, turn off the ignition, disconnect the module, and check the suspect terminal for corrosion and terminal tension. If all appears okay, there will be an internal resistance in the module. Move the meter lead from the sensor terminal to the next connector in line. In this case, it will be the ECM. Back probe the connector and retest. If the voltage is now correct, then there is an open circuit between the two connectors. If the reading is still 0 volts, then turn off the ignition, disconnect the module, and check the suspect terminal for corrosion and terminal tension. If this checks out okay, then there will be an open circuit in the ECM. Connect the meter lead between battery negative and the low reference terminal on the sensor connector. You should see 0 volts. Battery voltage would indicate a shorter voltage in the low reference circuit. Turn the ignition off and disconnect the ECM. If the meter now reads 0 volts, then the fault is in the ECM or another circuit from the ECM. If the meter remained at battery voltage, then there is a shorter voltage in the harness. To eliminate or confirm a short to another circuit, turn off the ignition, set the meter to ohms, and check for continuity between the sensor signal connector terminal and any other terminal in the ECM connector. If all tests are okay, then the fault is in the ECM. With the sensor disconnected, connect the meter between the sensor signal connector terminal and battery negative. A battery voltage reading will indicate that there is a short to voltage. Turn the ignition off, disconnect the ECM, and turn the ignition back on and retest. You should see 0 volts. If the battery voltage has not disappeared, then there will be a short to voltage within the harness. If the battery voltage has gone, there may be a short to another circuit coming from the ECM or the ECM itself. To eliminate or confirm a short to another circuit, turn off the ignition, set the meter to ohms, and check for continuity between the sensor signal connector terminal and any other terminal in the ECM connector. If these two tests are okay, then the ECM will have an internal short to voltage. With the sensor disconnected, connect the meter between the sensor signal connector terminal and battery negative. You should see between 4.8 and 5.2 volts. If the meter displays 0 volts, then there will be either a short to ground or an open in the signal circuit. A short to ground will set a P0107 DTC. Move the meter lead from the sensor terminal to the next connector in line. Back probe the appropriate terminal. If the meter now displays between 4.8 and 5.2 volts, then there is an open in the harness. If the meter is still at 0 volts, then turn off the ignition, disconnect the ECM connector, and check the appropriate terminal for the correct terminal tension and corrosion. If this is okay, then there will be an open in the ECM signal circuit. If the low reference, signal, and 5 volt reference are okay, the fault must be the map sensor itself. That's the diagnosis of P0108, map sensor signal voltage high. Make sure you have an understanding of how the circuit works before carrying out any diagnosis. Using the right test equipment will ensure you get the correct readings. Thanks for watching. See you next time.